Okay, this integral is not hard to do once you know what to do. If you don't know what to do, it is impossible. So on the test, everyone got it wrong, but now we can get it right. So the first step is I'm gonna draw an equal sign. I've always done my integrals just working straight down, and as I change something, I just go below it and then below it until I have an answer and I can circle it. But for this one, we're gonna draw an equal sign because it helps you see the answer a lot clearer. So the first step is to identify which term you use as your u. So use the acronym LIPIT. There's no logs, no inverse trig, no polynomials, and then exponent comes next. So we're going to use e to the x as our u. Go ahead and write that down. U equals e to the x. And then du will equal e to the x dx. And then that means our v will equal the integral of cosine 2x, which is sine of 2x over 2, and our dv will simply be cosine of 2x. So our first step is just normal integration by parts, vu. So we're going to go ahead and get e to the x sine 2x over 2 minus the integral of v du. So we'll get e to the x sine 2x over 2 dx. And then from here, I'm going to factor out a 1/2 from this integral. So we're going to move this divided by 2 and just pop it right in the front. And this is the point I got to in my test, and I was like, what do I do from here? Because it's going to keep going forever and ever. And what you do is you keep going. So we're going to do integration by parts again. Here we're going to use the same e to the x. U is going to be e to the x. Du is e to the x dx. V is the integral of sine 2x, which is simply negative cosine 2x over 2. And then dv equals sine of 2x. So I'm going to rewrite what I have so far, lower down with more space, and with the next step. So e to the x cosine 2x equals e to the x sine 2x divided by 2 minus 1/2. And then I'm drawing brackets so we can go ahead and start plugging these in. So now we can put in our vu. So we're going to put minus e to the x cosine 2x over 2 minus the integral of e to the x times negative cosine 2x over 2 dx. And we'll close the bracket off. And then from here, I'm going to go ahead and factor out this negative 1/2. So this becomes a plus 1/2, and we'll get rid of the negative and the 2. And then I'm going to distribute this this 1/2 out. So this will become a 4. I'll go ahead and distribute the whole negative 1/2. This becomes a positive, and then this will become a negative 1/4. And then I can go ahead and get rid of these brackets. So this is where this equal sign makes it more clear what to do. We can treat this whole integral as its own term, and we have this term over here and this term over here, and they equal the same thing. So what we're going to do is we're going to move all of this integral over to this side. So we're going to add 1/4 of the integral of e to the x cosine 2x dx equals, and then what we have so far, and then from here you simply multiply by 4/5 to cancel out this fraction. We multiply by the reciprocal. And then you end up with the integral of e to the x cosine of 2x dx equals 4 e to the x sine 2x over 10 plus 4 e to the x cosine 2x over 20. And then of course simplify your fractions. 4/10 will become 2/5, and then 4/20 becomes just 1/5, didn't even do 1. And then, because it's the integral, plus c. So your final answer is this. And now we can check that integral by taking the derivative of it. So the easy part is the plus c, constant, the derivative will always be 0. And then here I'm going to factor out 2/5 of e to the x sine 2x plus 1/5 e to the x cosine 2x. And then we can just use product rule. So we do 1 prime 2, which is going to be 2 cosine 2x plus 2 prime 1. That's going to rewrite that neater. E to the x. And then plus 1/5 of the same thing, but this time it will be negative 2 e to the x sine 2x plus 2 prime 1 will just be e to the x 2 cosine x. And then from here, I'm going to go ahead and distribute these back out. And then we can see that this plus 2 e to the x sine 2x over 5 and this minus 2 cancel out. And then we have 4/5 e to the x cosine 2x plus 1/5 e to the x cosine 2x, which simply equals e to the x cosine of 2x.